Good morning. This is day 2 of 141. What we're going to do is we're going to go over a market problem, and we're going to look at our producer and consumer surplus. We're going to look at how that changes when it's a monopoly. Remember, we're reviewing the monopoly chapter this week before we move on. So we're going to hammer this quantitative analysis, make sure we understand it, and that's going to be our topic of conversation this afternoon. When we meet over Zoom, is making sure that you really truly understand this. Okay, so let's say that we have demand for turnips that's given by that, and supply that is given by, and you might think that turnips are a little bit funny, but this is farming. Your kids are going to make all sorts of plants, vegetable plants, pizza plants, you name it. So turnips aren't that weird, so we'll go with turnips. I even like turnips once in a while. All right, so if we were going to guess what the market price and quantity would be, we would look at the relative slopes of my supply and my demand curve. And I can draw a graph, and I can just start off with demand. And relative to the slope of this demand curve, my supply curve is a little bit steeper. Supply starts at $2, demand starts at $10. So my market price should be somewhere between $10 and $2, but closer to $10 than $2 if I have drawn my graph with any accuracy whatsoever. So P is equal to P, so I can set my right sides equal to each other. 10 minus 0.002Q is equal to 2 plus 0.003Q. And notice that I dropped the subscripts on my Q's. And that's because a quantity of a turnip it's a turnip. They're always the same thing. And we're looking for the price where the quantity supplied equals the quantity demanded, so Q is just equal to Q. So add 0.02Q to the right side, subtract 2 from the left side, and I end up with 8 is equal to 0.005Q. And when I divide both sides by 0.005, of course this is just equal to Q, excuse me, 0.005 not Q, that would be equal to 1. And I get Q is equal to 8 divided by 5 is 1.6, 16, 160, 1600. So my quantity is 1600. And to find my price, I put 1600 back into supply or demand. P is equal to 10 minus 0.002 times 1600. 10 minus 0.002 times 1600 is $3.20. 10 minus 320, and if my price is $6.80. Now, about 2 minutes ago in this video, I drew a graph and said the price is going to be between $10 and $2, but because of the slopes, I think that the price will be closer to $10 than $2, and it is. It's $3.20 away from $10, but it's $4.80 away from $2. So we have a price, we have a quantity. To find producer and consumer surplus, here's my consumer surplus, here's my producer surplus. I just need to find the areas of those triangles. To find the area of the triangles, we just need their dimensions. The dimensions of my consumer surplus triangle is 1600. 1600 is the base, $3.20 is the height. And see how I got that was $3.10 minus 680. And intuitively, you should be able to start seeing how finding the area is a dollar amount and how it really is consumer surplus. There are 1,600 turnips that are bought. there's $3.20 thereabout of surplus with the first turnip, and a little bit less as we go on. So we're multiplying this 1,600 times this $3.20, but we're dividing it by 2 because we don't have consumer surplus up here. There isn't a rectangle of consumer surplus. We have to have it. So consumer surplus, $3.20 times 1,600 divided by 2 is equal to $2,560. And my producer surplus can be found the same way, $4.80 times 1,600, all divided by 2, and I get $3,840. And we refer to these two things together as market welfare. You like consumer surplus, it's the value you get you don't have to pay for, but producers like it as well. It's the price above their marginal cost that they receive, that they would take a lower price, but they don't have to. Okay, so now we're going to see what happens when we change this market to a monopoly. And what happens when we change the market to a monopoly is we can think about the supply curve as marginal cost. There's nothing that's changed in the technology or the way that turnips are produced. But what has changed is now there's only one firm, and that one firm decides the quantity, which then in part returns the price. And the monopolist is going to maximize profit exactly the same way that a perfectly competitive firm would. They're going to produce as long as their marginal revenue curve is greater than marginal cost. So we have to find the marginal revenue curve. And to find marginal revenue, we need to find total revenue and then find the change in total revenue. So total revenue is equal to price times quantity. And my marginal revenue is going to change as quantity changes, and I'd like this to be in one variable. And if I look up here, my price is equal to 10 minus 0.002 QD. This term can be substituted for P, and now I have total revenue in one variable. So total revenue is 10 minus 0.002 Q times Q. And if I distribute that in, my total revenue is equal to 10Q minus 0.002Q squared. Now, this minus 0.002Q squared is the functional form of the total revenue curve. And you had this in high school math. At some point, you had a parabola, and then someone put a negative sign in front of it, and then split it upside down. And so we would say this is a second order polynomial. And what it's really saying is, well, I've got this flipped parabola, but I've got some other funny stuff going on with it. And what it's saying is your total revenue increases, but at a decreasing rate, just like the parabola. And we see my two different terms. As my quantity goes up, so too does my total revenue because I'm selling more. But as my quantity goes up, my total revenue goes down by this factor because the price is being lowered for all of the products. Remember, this is a one-price monopoly. So my total revenue function looks like that. Well, what I'm really interested, though, is marginal revenue. How does revenue change as I increase the quantity? I'm looking at my additional revenue and comparing that to my additional cost. And as long as that marginal revenue is greater than the additional cost, I'm going to be adding to profit. And the way that I do that is by finding the first derivative of my total revenue function. Marginal revenue is equal to 10 minus 0.004 Q. Okay. For those of you that are allergic to calculus, it's always, just like the demand curve, minus twice the steepness. It's what it always ends up being, and it's because of this squared term. So if we set our marginal revenue equal to marginal cost, 10 minus 0.004 Q, and we set that equal to our supply curve, which was 2 plus 0.003 Q, we can now solve for Q. Add 0.004, subtract 2, and I get 8 equals 0.007 Q. And we're going to get some nasty numbers. Divide both sides by 0.007, and my quantity is equal to 1,142.86. So as we would have estimated, the monopolist maximizes profit by restricting quantity, just as our graph anticipated. But now we need to find the price. If we put this quantity back into marginal revenue, 10 minus 0.004 times 1,142.86, I end up with a price of $5.43. Now, be careful. That's not the price. If you're plugging and chugging, say 543, I put that into marginal revenue, I put it into marginal cost, or this 1142, it's going to work. I'm going to get 543 for each one. That's not the price. That's the marginal revenue of the last unit. It's the marginal cost of the last unit. To find the price, we need to put our 1142.86 back into our original demand curve up here, and we get a price of $7.71. So 1143 times 0.002, we subtract that from 10. We get 771, which makes sense because our price was $6.80 before it was controlled by a monopoly, and a monopolist's goal is to restrict output, hike up the price, maximize their profits. We know the price is going to go up. So 771 makes sense. Okay. To find consumer and producer surplus, we do the same thing as we did before. There still is consumer surplus in this small triangle. It's equal to 10 minus 771 times 1142.86 divided by 2, and that is equal to $1,308.57. My producer surplus is now equal to this rectangle and this triangle, and this rectangle is 1142.86 times 771 minus 543. So my producer surplus is 1,960 plus the area of this triangle, 343, times 1142.86 divided by 2, my 2605.72. I think I just did those backwards. And I end up with $4,565.72. So, producers are much better off, consumers are far worse off. It is not, however, a one-to-one transfer. Certainly, this amount of consumer surplus in these two boxes were transferred to producers with no loss. However, this amount of consumer surplus is gone, and this amount of producer surplus is also gone. It just gets lopped off. And the reason why it disappears is because there's 457 fewer turnips that are produced. Excuse me. Those turnips each had some consumer surplus and producer surplus attached to each one of them, and it's now gone. Okay? That's called deadweight loss. It's not surplus that's transferred from one party to another, it just disappears along with the turnips. Okay, your question for this afternoon is to make sure that you understand this. We can go over some other problems. I'll probably do Zoom with the marker board so that I can answer more questions because I think you might have them. But otherwise, we'll see you in a couple hours, and hope things are going well.